simulation. Now we want to look at the relationship between volume and temperature. So where's the volume? Okay, volume. Okay, this one you see this one, I can increase or decrease the volume. And temperature. Okay, what we can provide heat or remove the heat. Okay, to see the how it responds. Okay, now this one is thermometer. Kita nak in degree Celsius, okay, or in Kelvin pun boleh. Okay, but for this topic, this is gas law. So for gas law, okay, if we have temperature, the temperature will always be in Kelvin, okay, especially during calculation. It's best if you keep the temperature always in Kelvin. Why? Later I will explain. So we should, now I want to see the relationship between the temperature and volume. So what must be constant? What must be constant? Okay, now I provide molecules of gas. I want to see the relationship between volume and temperature. Now referring to your smart triangle too, what should be constant now?
Pressure.
Hello, are you here? Yes, thank you. The pressure and the mass of gas. That means the number of gas cannot be increased anymore. So saya tak boleh tambah lagi gas. Okay, the mass is constant. So now, selain daripada mass constant, we have to make sure the pressure constant. I increase the temperature. What is changing? What do you observe? Oops.
Volume increase. The movement of particles.
What? Kenapa dengan movement of particles? Okay. What about the movement of particles? Higher lagi. What else did you see just now?
Volume they increase.
Yes, that's obvious. Not just now, the volume was that lah here sampai sini saja. But when you provide heat, now the temperature is 452 Kelvin, which is 179 degrees Celsius. So you see, when you increase the temperature, the volume will increase as well. Okay, so that's the relationship. Okay, pressure is kept constant. Particles of gas here. Okay, now I want the pressure to be constant. Okay. Now I change the, okay, now what's the temperature? 303 Kelvin, which is equivalent to 30 degrees Celsius. Okay, so if I reduce the volume, just the same just now lah macam tadi. So volume temperature relationship. So this one is Bourdon gauge. Nampak tak yang saya tengah gerak-gerakkan tu? This is an instrument to measure pressure of gas. The name is Bourdon gauge. So now the temperature is in Kelvin, 200 Kelvin. So the volume is 2 meter cubic. Now what happen if you increase the temperature? Panaskanlah. You increase the temperature, automatically the volume will increase. And look look at the molecules punya movement. Okay, the kinetic energy is, so now we can say the kinetic energy is
Increase.
High.
higher. Okay, the
Higher.
kinetic energy is higher. Okay. What else? Okay. If you reduce the temperature, the volume also reduce. So what is the relationship? So the relationship now is the higher the volume, the higher the temperature. Or the lower the volume, the lower the temperature. Okay. Stop presenting. Okay, now let's move to, okay, so that is Charles' law. The temperature, the volume will increase. Okay, so if you are asked about Charles' law, so the statement is Charles' law states that volume is directly proportional to absolute temperature. For a fixed mass, you must mention the mass is fixed, and then you must also mention the the pressure is constant. The pressure of whom? The pressure of the gas. Okay, so from this relationship, if you want to have the formula, what you need to do? You add a constant K here. So from there, you get K equals to V over temperature. This one. Okay. Now from there, if we have different conditions, condition before and after, just like the simulation just now, ingat tak tadi? Okay, so we can see, we can have this formula. Okay, V1 over T1 equals to V2 over T2. So this is the statement of Charles' law. Okay, I want to point out here, you must make sure when you measure the temperature ataupun when you want to do calculations to solve problems, the temperature must be absolute temperature. What does that mean? That means the temperature must be in Kelvin. Therefore, if you are given questions in degrees Celsius unit, you must change it to Kelvin. So the question is, how do you change temperature from degrees Celsius to Kelvin? So that is the first question you need to ask yourself. Second, you must ask, what is an absolute temperature? What is the meaning of absolute temperature? So that's question number 2. Question number 3, this graph. Just now, we mentioned that when temperature increases, volume increases. True or not? Setuju? Ada orang lagi ke tak ni? Very quiet.
Setuju.
Okay. Now, if you
Yes.
plot, if I have data, so my data is in centimeter cubic and degree Celsius. So if I plot the data, so these are my data. Logic lah kan? 10, 20, 30, 40, 50, 60, 70. So this is the data. So straight line is here. Now, if I draw the graph, so the graph is hanging like that. Your graph macam ni je. Okay, that the graph does not cut zero. There is y-intercept. Kan? This is V ataupun this is Y. There is Y-intercept. Do you remember mathematics you learn? So kita ada Y-intercept here. C kat sini. So, if this is the graph, we cannot say the relationship between V and temperature is directly proportional. Sebab Kita kata directly proportional if the graph cuts 0. So, we can explain this one. Macam mana? Okay, now. Okay, dengar baik-baik dan fahamkan my question just now. Okay, now. You carried out the experiment. So, buatlah eksperimen sepatutnya kan. The experiment is looks something like this. Okay, ada ada concentrated sulfuric acid and so on and so forth. And then this is your data. Okay. Now, when you have the data, when you want to plot the graph, okay, and then you have plotted the graph, okay, so you see that volume of gas increases when temperature rises. So that's obvious. Temperature rises, volume rises. Okay. Now everybody, please look at 0 degrees Celsius at the graph. Now we have the graph. So here is the graph. Now 0 degrees Celsius kat mana pointnya? This one kan? Yang the one that I highlighted. So awak pandai baca. You know how to read a graph. So now at 0 degrees Celsius, ada volume tak? Is the volume 0?
No.
No, the volume is not 0. Ada volume, ada nilai kat situ. C kan? Y-intercept. Okay, so here it says at 0 degrees Celsius, the air trapped in the capillary tube still has a volume. Now, this shows that at 0 degrees Celsius, gas molecules are still moving and filling up the space in the container. So that means kalau imagine a place atau satu mana-mana country that has 0 degrees Celsius temperature right now. Kat mana Sekarang ni winter sama. Sekarang ni bulan berapa ni? 3. Winter. Winter nak ke sama. Winter nak ke. Winter yang sekarang. Itulah kot. Katalah kat mana-mana lah 0 degree Celsius, kat New Zealand ke, kat UK ke kan sekarang ni kan, kat China ke. You katalah awak ada balang gas. Now you are in mana UK, in the UK. Now you are in the UK lah. Imagine in the UK. And then you have this box here. Okay, gas. Okay, gas container So this one in here gas. So it means now, even though the temperature is 0 degrees Celsius, there is also gas here and the gas is still moving. They are not freezing. Betul tak? You just imagine lah if you go to the UK and then at 0 degrees Celsius, semua gas molecules freezing, awak boleh bernafas tak? No, you will die kan? Kan semua gas-gas pun freezing. Maksudnya tak boleh berlaku lah. That will never happen. That's why lah we get this graph. Okay ke? Do you understand up to this point?
Yes.
Okay.
Yes.
So,
Okay.
and then scientists got something. Now, we have point out temperature point, we have absolute 0. Okay, so this one, the absolute 0 means, okay, the temperature in degrees Celsius is negative 273. Okay, and then temperature in Kelvin is 0 degrees Celsius. How do we get that? Saya extend masa sikit, sorry lah. Okay. Now, when you have, okay, tadi, let's say lah tadi, awak ada graph. Okay, let's say just now, you have graph. Okay, ni, this is your graph. Kan, dot tu. But when you extrapolate the graph, you buat dot, you dapati, okay, you found out that your graph will cross. Your graph will cut x-axis at a point. So, and when you use graph paper, this point gives you the value of negative 273 degrees Celsius. So that is what we call as absolute zero. Okay. So because of that is absolute zero, so kita when we have unit in Kelvin, so 0 Kelvin is at that point. Okay. And then this one also, you have learned this one, you know, melting ice temperature is 0 degrees Celsius. Steam, the temperature is at 100 degrees Celsius. However, if you change this into Kelvin, the values will be these. 0, we have 273 Kelvin. And then at steam, during steam, we have 373 Kelvin. So from here, we make a conclusion ataupun we get a formula. So this is a new thing for you lah. Okay, this formula will be used for you to convert unit from Kelvin to degree Celsius ataupun from degree Celsius to Kelvin. Okay, right? So if you have 0 degrees Celsius, how do you change that to Kelvin? Senang saja. 0 plus 273, that gives you 273 Kelvin. Please take note this one, yeah? And then, let's say you have 110 degrees Celsius. What's the value in Kelvin, class?
383.
Yes, you just add 110 plus 273. That gives you 383 Kelvin. It's simple as that. Tapi jangan tersilap lah. Kalau you dapat Kelvin, okay, katalah you ada 200 Kelvin. What's the value in degree Celsius? What you need to do?
Minus
200.
273.
Yes, 200 minus
Negative 73.
273. So what's the answer? Negative
Negative
73
73.
degrees Celsius. So now, scientists has come out with this graph. So this graph, volume against temperature as well. Tak sama ke? Sama je, jenis graph yang sama. This one also volume. This one also volume. This one also temperature, this one also temperature. But the only thing that is changing is the unit. So now, just now the unit is in degree Celsius. Now the unit is in Kelvin. I should have drawn the graph next to each other lah. Okay, so sepatutnya kat sini ni, kalau kat sini dia ada dekat tengah-tengah ni. Okay, so ini adalah 27, tak nampak, is 273 negative degree Celsius. Ni. Okay, so the graph tu kita ubahkan dia punya axis tu. So from this graph, so make sure lah, okay, if you want to see, if you want to draw the graph ataupun calculation, you have this unit is in Kelvin. Okay, so that gives us this statement of Charles' law. So from this graph, we get the relationship directly proportional. Okay. So the graph of V against T for gas shows a straight line passing through the origin. So this shows that volume of gas is directly proportional to, bukan temperature. You cannot mention temperature. You must mention
Absolute temperature.
yeah, you must mention this word. So now you know what is the meaning of absolute temperature. Okay, so this is what you have seen just now. You have watched in the simulation. Okay, temperature increases when volume increases. Okay, and then can you solve this problem? Of course, you can use what formula? How to solve this? An air bubble volume of 1.2 centimeter cubic. So we have volume 1 at temperature 273. So this is T1. What is the volume? So the question wants volume.
Volume.
So when you are given temperature 2. So how do you solve this problem? What formula can you use?
V1 over T1.
Okay, cepat-cepat. Nak siap Rabina? Okay, good. Thank you. V1 T1 equals to?
V2 over T2.
Okay, excellent. So now let's substitute. What's V1?
1.2 centimeter square.
Okay. Cubic, bukan square. T1, what's the temperature?
300 Kelvin.
Why 300? Tell me. Why 300?
Kena
Bukan
tukar aja
227.
pada Kelvin.
Yes, very good. Okay, excellent. Ada pun seorang student yang stay awake until the end. Excellent. Okay, right, that's fantastic. So your friend, okay, help everyone. So V2. Therefore, this one T2, what's the T2? 47 plus 273. Okay, well done. So if you know this one, so that's easy. You just plug in the numbers and then you will get the answer 1.28 centimeter cubic. But, okay, from my experience, this one students, okay, all those students, everybody memorize ataupun know this formula, but most students will get this wrong. Why? Because most students forget to change this one into Kelvin. Okay, kalau awak tak ubah, you will definitely get this wrong. So, that's it for today. Okay, and then maybe you can answer this question. Okay, I can put this one as your homework, right? So, please explain this. Okay, class. See you when I see you again. Assalamualaikum. Take care.
Assalamualaikum.
Terima
Terima kasih cikgu.
Okay.
Assalamualaikum.
Thank you, teacher.
Thank you, teacher.
Terima kasih cikgu.